Today we are going to see some more examples on time domain analysis. The open loop transfer function of a unity feedback system is given by the open loop transfer function of a unity feedback system. Therefore, h of s equal to 1. H of s equal to 1. Negative feedback system. Therefore, closed loop transfer function T of s equal to, if open loop transfer function with the unity feedback system is given, the formula is numerator divided by sum of numerator and denominator. That is equal to numerator, that is k upon s multiplied by tau s plus 1 plus k plus k. Or we can write k upon tau s square plus s plus k. Or we can write k by tau upon s square plus 1 by tau s plus k by tau. K by tau. This is the given transfer function. This is the given transfer function. Closed loop transfer function is given, where k and tau are positive constants. K and tau are positive constants. By what factor? By what factor should the amplifier gain be reduced? Amplifier gain be reduced so that the peak overshoot of the unit step response of a closed loop system is reduced from 75% to 25%. Here, we can assume the system like this. Here I am putting k 1 by tau. I am taking that k outside. S square, not 1 by tau, tau s. S multiplied by tau s plus 1. Why I am writing like this? Not this. This is closed loop transfer function. I am writing open loop transfer function. Open loop transfer function. The feedback is coming here. Negative feedback. H of s equal to 1. This is given. I am writing this k outside because k means gain. Gain means it is nothing but an amplifier. This is the amplifier whose gain is k. If amplifier gain equal to 2 means if you give 1 volt, it will make it 2 volt. The amplifier gain is 5 means if you give 1 volt, it will make 5 volt. So the k is an amplifier. Like that you have to assume. The open loop transfer function of a unity feedback system is given by, the open loop transfer function is given, where k and tau are positive constants. By what factor should the amplifier gain? Amplifier gain. It means the k is an amplifier. Reduced so that peak overshoot of the unit step response of the closed loop system is reduced from 75% to 25%. Earlier, the MP1 equal to 75%. Now, the MP1 peak overshoot is reduced to 25%. What is the relation between k and overshoot? K and overshoot. If you take the transfer function, you compare this with the standard form, omega n square upon s square plus 2 zeta omega n s plus omega n square. Here, in place of omega n square, k by tau is there. K is variable here. K is variable here. You can adjust the gain. So omega n is variable. Omega n is variable because k can be adjusted. The gain of this amplifier can be adjusted. The gain of this amplifier can be adjusted. That's why omega n becomes variable. As omega n becomes variable, omega n is variable. As omega n is variable, the zeta value will change because if you compare this 2 zeta omega n equal to 1 by tau. Therefore, zeta equal to 1 by 2 tau Sorry, I'm confusing this with the 1 by tau. Therefore, if you compare these two, what is zeta? Zeta equal to omega n equal to what? Because we have to substitute omega n. Omega n equal to omega n square equal to k by tau. Therefore, omega n equal to square root of k by tau. So zeta equal to 1 upon 2 tau omega n. But omega n equal to what? 2 tau omega n equal to square root of k by tau. That is equal to 1 by 2 root k tau. Am I correct or not? Zeta equal to 1 by 2 square root of k tau. So if you vary this gain k, definitely there will be a change in zeta. If you increase k, zeta will decrease. If you increase k, zeta will decrease because the relation is 1 by 2 square root of kt. If you increase k, zeta will decrease. That's why what is asked, the closed loop system is reduced from the amplifier gain. By what factor should the amplifier gain be reduced? How much k has to be reduced so that overshoot is reduced? Will increase. This is one response. This is another response. Let us assume that here zeta equal to 0.7. For this, definitely zeta will be this 0.2. For this, zeta will be 0.7. For this, zeta is 0.2. This is 0.7. As zeta increases, overshoot decreases. Zeta increases, overshoot decreases. So, we have to reduce the overshoot from 75% to 25%. That's why we have to increase the zeta. Zeta has to be increased means k must be reduced. K must be reduced. If you reduce, zeta automatically will increase. Zeta has to be increased so that the overshoot should be reduced from 75 to 25%. How much? By what factor we have to increase k? Because if you increase k, what will happen? Zeta will decrease. Now we have to increase zeta. That's why we have to decrease k. We have to decrease k. The relation between zeta and k is 1 by 2 root k tau. That's all. Now we'll find zeta 1 equal to 1 upon 2 k1 t. Can I say like that? Because there is no change in t. There is no change in t, only k is varied. Zeta 2 equal to what? 1 by 2 square root of k2t. Two different k's. We have to find the relation between k1 and k2. For that, first we have to find what is zeta 1, what is zeta 2 we have to find. For that, the 78% and 25% are given. What is the formula? MP1 equal to 100 e power minus zeta 1 pi upon square root of 1 minus zeta 1 square equal to 75%. 75%. It means what? E power minus zeta 1 pi square root of 1 minus zeta 1 square equal to 0.75. Therefore, zeta 1 minus zeta 1 pi upon square root of 1 minus zeta 1 square equal to ln of 0.75. ln of 0.75. ln of 0.75. Therefore, we can find zeta. ln of 0.75 negative value. Therefore, what is 0.75? ln of 0.75. It's not given. Zeta 1 directly given. 0.091. This implies zeta 1 square pi square upon 1 minus zeta 1 square equal to ln of 0.75 minus sign. So this minus sign will getting cancelled. Therefore, zeta 1 equal to 0.091. 0.091. Similarly, we can find zeta 2. For zeta 2, what is the overshoot? For zeta 2, the overshoot is 25%. Therefore, we have to substitute 25% equal to 100 e power minus zeta 1 pi, zeta 2 pi upon square root of 1 minus zeta square equal to 25. Or we can say that minus zeta 2 pi upon square root of 1 minus zeta 2 square equal to ln of 0.25. This implies zeta 2 equal to 0.4037. Zeta 2 equal to 0.4037. 4037. That is second equation. First, we got zeta 1 equal to 0.091. What is the relation between K1 and K2 we have to find? So substitute the value of zeta 1. Zeta 1 equal to 0.01, not 9, 0.091. Zeta 1 equal to zeta 2 equal to 0.4037. Zeta 1 upon zeta 2 equal to zeta 1 equal to what? 1 by 1 upon 2 square root of kt, k1t whole divided by 1 upon 2 square root of k2t. One upon k2. That is equal to 2 getting cancelled. Therefore, this implies zeta 1 upon zeta 2 equal to square root of k2t upon square root of k1t. Or we can say that zeta 1 by zeta 2 equal to square root of k2 upon square root of k1. Or we can say zeta 1 square upon zeta 2 square equal to k2 upon k1. That ratio we have to find. Zeta 1 square equal to what? 0.091 whole square divided by 0.4037 whole square equal to k2 by k1. Therefore, by what factor we have to reduce k? Therefore, k2 equal to by what factor? That factor we have to find times k1. K1 is higher. K1 is higher. That's why more oscillation. So from that we can understand two things. First, let us find what is that value. Zero point zero five. 0.0508. 0.0508 times K1. Suppose K1 is 1 means the present gain should be 0.0508. So we have to reduce by this factor. This is the answer. We have to reduce the gain by this factor. This is very, very important sum. We are understanding many things from this sum. Let us look at this. By what factor should the amplifier gain be reduced? We have to reduce the gain by 0.0508. Suppose the earlier gain is 1 means we have to reduce the gain of this amplifier to 0.0508. That is the meaning. Then the oscillation will be reduced. It means another information is there. If you increase the gain of the amplifier, if K of the static gain of the system increases, in closed loop oscillation will increase. If we increase K, what will increase? Oscillation will increase because zeta will decrease. Zeta will decrease. That's why oscillation will increase. While studying about stability, we will study all those things. We'll see in the next chapter about stability. That time, this K will plays an important role. So if we increase K, the oscillation will increase. If we increase, zeta decreases from 1.7, 0.3, 0.2, 0.1, like that it decreases. If you further increase, what will happen? At one point, zeta becomes 0. Zeta becomes 0. Zeta becomes 0 means undamped oscillation. Always it oscillates, never settles. So that is also possible. By changing the amplifier gain, we can change the oscillations in the system. We can change the oscillations in the system. That's why speed is dangerous. If you give accelerator, you are increasing the gain K in the bike or the vehicle. If you increase, you are decreasing zeta. You are decreasing zeta. That's why suddenly something happens, you are oscillating. You cannot take the decision. That's why it leads to accident.